The purpose of this video is to give you a little bit of background information about the chemical reaction that's going on in experiment one, how we're going to be developing our experiment from a scientific question and generating a hypothesis, and then how you're going to organize your data for the experiment. So what's shown here is the chemical reaction for the experiment. We have sodium bicarbonate is what this is called, sodium bicarbonate, which is a solid white powder. That's what this S here means. This means that we have a solid. And the solid sodium bicarbonate, we're going to be reacting with acetic acid. And acetic acid is a solution. So this aqueous notation here means that it's dissolved in water. So this will be a clear liquid that'll look just like water, but it's not actually water. It is a molecule, this molecule here, dissolved in water. And then we are going to form, so these are our two reactants, and then this arrow divides the things that we're starting with, our reactants, from the things that we're going to end with, which are our products. So the products are the things that are going to be produced. And the products of this reaction are carbon dioxide, which has the chemical formula CO2. You're probably familiar with that one. You're definitely familiar with water, H2O. CO2 is a gas. Water, we know, is a liquid at room temperature. We're going to be running this reaction at room temperature. And lastly, the product here, sodium acetate, which has this chemical formula and this structure here. And this is also aqueous, which means that it is dissolved in water. So this is our chemical reaction. We're taking this sodium bicarbonate molecule, and you can see that there's a sodium, a carbon atom, 3 oxygen atoms, and a hydrogen. We're reacting that with something that has these 4 hydrogens, 2 carbons, and 2 oxygens. And then we're forming, you'll notice the atoms in the product are the same atoms that were in the reactants, but now they're rearranged. So instead of, like, for example, instead of this carbon here being bound to 3 oxygens, now in the products, we've got a carbon bound to 2 oxygens, an oxygen bound to 2 hydrogens. So this chemical reaction, and all chemical reactions really, are just atoms rearranging. So we're starting with atoms in one configuration. We're going to mix them together, and mixing them together literally means that these molecules are going to collide in solution. When you're shaking your reaction, you are shaking together the sodium bicarbonate molecules with the acetic acid molecules. And as those molecules hit one another, atoms are going to break off and form new bonds. And the new bonds will be these new molecules that are formed. So throughout your chemistry course, you are going to learn a ton about chemical reactions, how they happen, and all of that. But it's important to keep in mind the molecular structures. What's really happening here is that atoms that were arranged in one way are now going to be smushed together, literally physically bouncing off one another until they recombine to form these new products. So this is our chemical reaction. And this is actually a chemical reaction that, despite all of this here looking very complicated, you all have seen and probably done this chemical reaction before. And let me give you a little hint here. So sodium bicarbonate has another name. Its other name is baking soda. Acetic acid you probably have in your closet at home. Acetic acid is just vinegar. A dilute solution of acetic acid is household vinegar. And we're forming carbon dioxide, water, and this sodium acetate salt. So now that I call these, vinegar and baking soda, you probably know, okay, when I mix these together, it's going to bubble, it's going to fizz. And the fizz that you see is really the carbon dioxide gas being produced. So this chemical reaction is one that we are familiar with. We know what happens when we mix sodium bicarbonate and acetic acid. We're going to form carbon dioxide, water, and sodium acetate. So our experimental question is not, what happens when we mix together sodium bicarbonate and acetic acid. We already know what happens. We're going to form carbon dioxide. We're going to form water. The reaction's going to bubble. We already know that. So the purpose of our experiment is not to figure out things that we already know. It's to investigate something that maybe we don't know just yet. So in this case, we're going to be looking at the relationship between the quantity of sodium bicarbonate in the reaction and the amount of carbon dioxide that will form as a product of the reaction. So our testable question here is not going to be what happens when we mix sodium bicarbonate and acetic acid. Our testable question is instead going to be investigating the relationship between sodium bicarbonate and carbon dioxide. So in the reaction above, so we've already described the reaction. So in the reaction of sodium bicarbonate with acetic acid, we have the chemical equation for the reaction written in our notebooks. Anytime there's a chemical equation, you should write it in your notebook. So we've got the chemical equation. In this reaction, how does the amount of sodium bicarbonate influence the amount of carbon dioxide, CO2, that will form? So if we're mixing these things together, if I change the amount of sodium bicarbonate, if I increase it or decrease it, how will that affect the amount of carbon dioxide that will form in the reaction? And so from our question, we generate a testable hypothesis. And our hypothesis will have the relationship that was described in your pre-lab material. So our hypothesis can be, in this case, some sort of if X, then Y. So if I do something, then something else will happen. And so you might be looking at this and thinking, well, I already know what's going to happen, but you haven't tested it with experiments. So let's generate a hypothesis. We might think we know what's going to happen, but we have to test it with experiment. So in this case, my hypothesis is going to be if more sodium bicarbonate is added to the reaction, more CO2, carbon dioxide, will form. So that's my hypothesis. This is my question. This is my hypothesis. And we have to think about now how we are going to design an experiment to test this hypothesis. And so in this case, it's important to remember and be able to identify our independent and our dependent variables, and then to determine what variables we want to control. So in this case, we need to know what is the independent variable. So what's the variable we're going to change? What is the dependent variable? And then what are variables that we want to control? So controlled variables. So remember, a controlled variable is one that we want to stay the same. The only thing that we should be changing in our experiment is the independent variable. So if we're changing the mass of sodium bicarbonate and trying to see what happens to the amount of CO2 produced, we want to make sure that everything else stays the same. So there's one key controlled variable that we need to make sure we have in this experiment. We're going to be changing the amount of sodium bicarbonate to see how much carbon dioxide forms. We need to make sure that we are using the exact same volume of acetic acid across all of the reactions, across all of our tests with different amounts of sodium bicarbonate, because otherwise we won't know if it's the sodium bicarbonate change that's changing the amount of CO2, or if the acetic acid is influencing this. So when you're thinking controlled variables, you're thinking about things that should be the same in all of your trials. So your independent variable is the thing you change. Your dependent variable is the thing that changes as a result of you changing the independent variable. And the controlled variables are things that should stay the same. So in your experimental design, you want to make sure that you have your controlled variables identified and maintained the same throughout all of your different experiments. So things like temperature, your amount of acetic acid that you're going to use, maybe the size of the flask, the duration of the reaction. There's a lot of different controlled variables. So just make sure you're thinking about those as you're going through. So this is the experiment that we're going to be doing. You're going to be changing the amount of sodium bicarbonate in this reaction and measuring the amount of carbon dioxide that is produced. And you'll watch the procedure video to see exactly how we're going to do that. So the last thing I want to talk about here is how we can organize our data tables. So the data that we're going to be collecting, we're going to be identifying the mass of sodium bicarbonate, which is NaHCO3, and we're going to be measuring this mass in grams. And then what we are determining as a result of the experiment is the volume of CO2 produced. And we're going to be measuring that in milliliters. So these are our table headings. And then over on the side of our table, we will have trial 1, trial 2, and trial 3. So what this means when we've got separate trials in our experiment is that we are going to have 3 sets of data from the same test. So your mass of sodium bicarbonate should be the same for all 3 of these, and you'll get your mass assigned to you in class because we're going to be compiling all of the class data. So you're going to be given a mass, and you're going to run 3 trials of the experiment where you're going to measure out a certain amount of sodium bicarbonate. You'll record the masses here. You're going to run the experiment, and then you will measure and record the volume of carbon dioxide produced. So when you're preparing your lab notebook, you prepare a space to record that data because we know what data is going to be collected. You're going to collect this data here. So now you have a nice organized place to keep track of it in your lab notebook. And so in your data table is organized as the independent variable, and then your dependent variable. And this organization is important because it will allow us to later very easily create a scatter plot. So after we get our data, we're going to be generating a scatter plot in Excel, and we'll go through how to do that in class. So when you generate a scatter plot of data like this, your independent variable will go in your x-axis, and your dependent variable will go along the y-axis. So each set of data, I'll just put in some made-up data here. Say I got 0.105 grams, and that produced 12 milliliters. Note that I've got the units in my header, so I could also write them next to my values here, but I'm just going to leave them in the header. So it's important to make sure that you always have units associated with your number, but in a data table, you can just put those units in the heading. So here, this will be my x value. My x value is going to be 0.105, and my y value is going to be the 12. So 0.1 would be my x value, and then if this was like 10, 12 might be a little bit higher. So this would be that data point. And you will have 3 data points from your experiment that hopefully will all be, largely the same, because ideally when you're running 3 trials of an experiment with the same mass of sodium bicarbonate, we'll get the same volume of carbon dioxide produced. But that's not necessarily going to happen. That's why we run 3 trials to make sure that we are getting reliable and reproducible data. So this is how your experiment will go. You're going to run your reaction. You're going to do 3 trials. And then at the end, we're going to compile all of the class data to generate a big scatter plot with everyone's data. After we have a scatter plot with everyone's data, this is just made up data points here. what we're going to do is create a line of best fit. Excel will do this automatically. And from that line of best fit, we'll be able to observe a trend potentially. There might be no trend. The trend might be the opposite of what we are expecting from our hypothesis. But either way, from all of this data, we would be able to draw the conclusions and answer our scientific question and either confirm or refute the hypothesis that we had. So that's the overall objective of this experiment. And I hope you all learn a lot from running this experiment about the scientific method, get a little bit of an introduction to chemical reactions, thinking about molecules combining, rearranging, and forming new molecules. So keep all of those things in mind as you are running the experiment. Get your lab notebook organized before lab, following the rubric, organizing your data tables, and then you will be all set to go in lab.